Deep Learning and CV course for spring 2026, and I'm making this recording to walk you through my project for the basketball game analyzer repo. So I have two notebooks. The first one is doing the commentary analysis, and the second one is actually doing the video tracking of the players. In the first notebook, the task here, so each notebook corresponds to task 1 and 2. Notebook 1 is regarding task 1. For task 1, it analyzes the player performances using only the in-game commentaries, and I built a RAG or retrieval augmented generation system with faster whisper transcription, sentence transformer embeddings, and Coin 2.5-14b running locally with Olama. So that's my local LLM agent rather than using ChatGPT or Gemini for the API calls. I'm choosing to do everything locally. So all the libraries are installed. That's happening right now, as you can see. They've been imported successfully. Now the transcript is going to be loaded. That has been loaded successfully with nearly 2,000 commentary segments. It's about a 94-minute duration, and that corresponds to the length of the video from the project page. Then the embedding index is built. That's done. And now finally, this is the QA function. So this is me asking the LLM questions, and the llama will answer back based on the commentary that has been parsed. So that's ready. I have three, four, 5 questions. So in this case, I've chosen to pre-write the questions and have the LLM respond to them. Another way to do it is to do it interactively on the command line and converse with the LLM as one would typically do in an online mode, like ChatGPT or Gemini or Claude. So here we have the answers from Olama. Uh, the thing to notice here would be that timestamps are being clearly referenced from the commentary, and there are some disclaimers here and there regarding the answers. And the disclaimers exist simply because the LLM does not have real-time access to the game itself. So there might be some deviation, or it, the answer may not be 100% accurate. But that's effectively task one. And then we move on to task two. So task two is actually the main thing for this project. So again, the environment has been set up. It takes a couple minutes. So again, we will begin this video with task two of the project. So this is why we verified the player actions for the videos. The project folders are ready. We just want to make sure that the GPU is detected. In this case, I happen to have a RTX 5070 Ti and an AMD 9800X3D processor. You want to make sure that all the required packages are installed. We also want to download the YOLO checkpoint, and then we start by chunking the video into place. So the video that was provided in the project repo, and this in my implementation turns into 332 video chunks, and the corresponding metadata is saved as well. And then we have to re-encode the clips to H.264. So this takes a good 10 to 20 minutes. In this case, I have written scripts in the background that have taken care of the sort of heavy lifting. So the notebook is really relying on data that has already been re-encoded, which is why it won't be possible to see a 10 to 20 minute wait time at the moment. And then what I want to do is actually do some recognition of the players. So I know I have two blank images, but effectively what I'm trying to do is um, to tell my OCR to differentiate between the yellow jerseys of the Lakers players and the blue jerseys of the Oakland Warriors. So you will see that the Lakers are being identified, but when a Lakers player is standing next to a Warriors player, the OCR does not or is unable to um, do two separate detections. Rather, it lumps everyone into one bounding box itself. Additionally, I was hoping that the OCR would be able to pick up on the jersey numbers and actually tell me which player corresponds to the jersey number. Um, but given the uh, inability or the complexity surrounding OCR number detection, I've chosen a slightly simpler approach and just try to classify if a player is from the Lakers or from the Warriors. So again, I have the detections, and this is the other blank image. Um, and here are the visual summaries that correspond to the frames. So I'm trying again to have a LLM based summary that corresponds to the picture. So for example, if we take a look at this picture, for example, the summary clearly says that the Warriors are handling the ball in transition as the Lakers set up for defensive position. That is more or less visible from the picture. The players are exhibiting athletic movement. That's also clear, and one can also see the tactical positioning that the players are engaging. One can also see the referee monitoring the game, but because the referee is wearing a blue jersey, they're being classified as a Warriors player. In this case, it's also interesting to note that the jersey number of the referee, despite it being 23, is somehow being picked up as 83, and it's reflected in the label. So the OCR system, with regards to recognizing jersey numbers, does work, but it only works if the number is fully visible. If you see player 23 from the Lakers, they are facing a little bit away, so the cameras aren't able to fully detect the number 23 on their jersey. So for them, the number 23 is not appearing in the bounding box label. So overall, for this project, a hybrid system is better that combines the commentary retrieval augmented system with the video evidence for um, making sure that the players are tracked and that the images actually match the answers given by the other one. So that's my project, and I hope that you were able to find this useful. Thank you.